In the last section, we started on our node implementation. We put together the constructor and the add method. We're now going to move on to the remove method of a node. So the goal of the remove method, let's take a look at a diagram here. We're going to call remove, which is a method on a node. So maybe we will call the remove method on this node right here. When we call it, we're supposed to pass in some data. So given some data, we're going to look at each child element of the current node. So if we call remove on this right here, we're going to look at this node and this one. As soon as we find a node, one of these children ones, with some data equal to the data that was passed into remove, we're going to remove that node entirely. So if we call the remove method on this node right here and pass in some data of maybe 4, 5, 6, we should look at this node right here. We should see that 4, 5, 6 is equal to the 4, 5, 6 that we passed into the remove method, and so we will delete that node. We'll then look at the next one. We'll see that it has 7, 8, 9. That is not equal to 4, 5, 6, and so this one can stay around. So the add and remove methods are pretty straightforward, right? We're looking at a single individual node here and trying to manipulate its children. The add and remove methods belong to every node. So we could have just as easily called add onto this node right here or onto this node, and essentially you get the idea. That's how we can build out our tree structure. So let's give a shot at this remove method. Now this one's going to be a little bit more tricky because we're going to have to iterate through a list of records and somehow remove some elements in it. So I'm going to define my remove method. It's going to be called with some amount of data. And then inside of here, we're going to look through every child of the current node. And as soon as we find one that has data equal to this data argument right here, we need to somehow remove it from the array. So this is going to be a classic case of where using our array filter helper is going to be very useful. Now, if you don't recall how the filter helper works, let's do a very quick example over in the code editor here. So we could say const arr equals 1, 2, 3. And then if we called arr.filter, and then we can pass in a function with it, so maybe something like element like so, and then we need to do some type of Boolean check in here, or some type of logic. For any element that we return true for, that element will be maintained in the output. Otherwise, if we return false, then the element will be removed from the array. So if we did something like return element equal to 1, then you can see that every element that does not satisfy this check right here is removed from the array. Now, one thing that's really important to note here is that when we call filter on an array, it does not modify the original array. So if we call filter and then print out array, it still has 1, 2, and 3. Whenever we start to call filter right here, this returns a brand new array. So we would have to do something like arr equals. And at that point, we would have to update this to be let instead. So we are reassigning the arr variable here with the newly filtered array. And that's exactly what we're going to do for our children array. We're going to call filter on children. We're going to look at every node value, and then we're going to reassign the children property. Okay, so over here at remove, we'll call this .children.filter. And for every node in that array, we'll do some type of check. So we'll say return node.data that is not equal to data. Oops, just 2 equals. So notice in this case we used not equal to because with filter, if we return true, that means we want to keep the element. If we return false, that means we want to remove it. So I want to return true for every element that is not equal to this data argument. If it is truthy, then, or excuse me, if it is falsy, if we have something that does not equal data right here, well, that means that we want to remove it. All right, so again, this does not modify the underlying children array. So after doing this filter call, we will assign the result to this .children, like so. All right, let's check out our tests, and it looks like everything's passing now. Now, before we move on, I want to show you the test file that we were just working on because it's going to give you a little bit more context on exactly how we can assemble a tree out of this node class right here. So inside of my tree folder, I'm going to open up the test.js file. Then inside of here, I'll scroll on down to the node can add children test right here. So in this example, you can see that we are creating a new node with some data A. We then add on some element B. So N now has one child, and that child is a node with data B. We can then make an assertion about the number of children that N has, or we can access that child directly by looking at the children array and getting the first element out of it. And then we can say, look at the children that that element has. So this would be the children of node B right here. And this test is just asserting to make sure that node B doesn't end up with any children because we didn't actually add any in this case. All right, so that's our node implementation. We're now going to take a quick break, and when we come back, we're going to start working on the tree class right here. The tree class is where things start to get really interesting. So this is where we're going to actually start to traverse our tree in some fashion and try to make use of the actual structure. So let's do a quick break. We'll come back in the next video and start to tackle the tree class.